Good morning, everyone. Carousel would like to welcome you to our Collibra webinar, Data Quality and Observability, Most Embarrassing Data Moments. At this time, I would like to introduce our speaker for today, Eric Gerstner, the Data Quality Principal at Collibra. Eric, the floor is all yours.
Hey, I just want to take a second and talk through the Data Citizens. This is an event that is going to be going on November 1st through 3rd. Looking forward to having anyone who would want to attend. You can look forward to opportunities for networking, innovative discussions, as well as some specific data-driven stories by both Collibra's finest and their finest customers. Just a quick event overview there. It will be November 1st through November 3rd. Location is the beautiful San Diego, California. We're expecting a large turnout, but we do have a special government pricing available. So looking forward to any one of you who would want to join. Please take an opportunity and consider it. So with that said, just want to do a presentation for you. When I think about a lot of these discussions and presentations, oftentimes we find that people do a really good job of bringing you the bottom line up front. I call this presentation my most embarrassing data moments. I say most embarrassing because there's a lot to be said for the pain endured here. These are real events that have happened to me in my time in data, and I share them with you so that you can hopefully feel that pain, have that empathy, and with that comes insight. I would use the anecdote of gravity. Gravity was discovered with an apple falling on someone's head. Now, to be fair, was it the pain of that apple that then drove that insight that something like gravity must be pulling it down on top of someone? So I am Eric Gerstner, again, really excited to be presenting to you today. Before coming to Collibra, I was the chief product owner at a major financial institution that underwrote the secondary mortgage market. Before that, I was a product owner for data quality tools at another major bank. And then before that, I was a consultant in data analytics, doing a lot of the day-to-day jobs that we see and face as data operators. I'm sharing these stories with you in hopes that you can feel the pain and then collectively walk with me on the journey to the insight that I've had. So just to talk about the way that this presentation, this overview would look. In the upper left-hand corner, we have kind of a mantra, right? It's just something that is part of our journey for which data quality will occur. In the right-hand corner, we just have kind of a question or some of the lingering things that I've been left with. And this is then based off of an anecdote that's in the lower right-hand corner. So starting with this idea of good model, bad data. So good model, bad data. I think about this idea of what is a model, and we could talk about it in terms of the analytics framework. We oftentimes hear this described a multitude of different ways. Ultimately, though, it's typically confined to three layers. This idea of raw data, which is processed into information, and that information is then analyzed or further refined into insight. So data to information, information insight. Now, in the technical landscape, we might consider this the unconformed or the non-conformed, conform zone, analytics zone. There's a lot of ways to think about this idea of model, but the key theme is these three layers are what we see perpetuate. And it's not just applicable to people in industry. We do see this in the government. The analytics cycle is oftentimes refined to this idea of going from data to information, information to intelligence. But the key idea is that the lead operator or the decision maker, perhaps the head of a government agency or perhaps the head of an organization, would be able to make a good decision given good insight. So we trust these leaders to make good decisions given good insight. And in the case of model, this could also be applied to technology. We would trust technology, systems engineering output to make good decision based off of good insight. But what happens when the data is bad? If at the root cause the data is bad, then the information would be bad and then the insight bad. And thus then we would run into a bad set of output, despite the model being good. And that's what we're talking about here. So just to kind of tell this story. So I was a product owner for data quality We were onboarding a marketing customer. Now, this could be relative to any one of us, this idea of someone who is working with proprietary data, source data. Maybe an agency has collections that they don't own, but data that is coming into an organization and you question its quality. So this marketing team had questions on the quality of its data. We started to look back and we realized that over the last 2 quarters, their data was coming in incomplete and sometimes not at all. So to qualify this, we have a model that was making marketing decisions near the total of 7 figures based off of incomplete data. So this is a huge deal, and this becomes something that receives a lot of oversight. We got pulled into a room. The steering committee looked at us. The person in charge said something to the effect of, well, why wasn't someone checking the data every day? So I think about that, and that's what kind of leaves this then question: what does monitoring data look like? How do I respond to someone saying, well, why didn't you check the data every day? What does that really mean? How would you know today's data is different from yesterday's data? What in your brain would be able to look and perform that trend analysis? So in keeping with that, I think that we have a few opportunities for lessons learned based on that anecdote. And this then brings in the second type of slide that you'll see. Observation controls are necessary. We expect things to go wrong, but sometimes we don't know how to check them. Predicting what will happen tomorrow is impossible without observation. So being able to trend yesterday goes more than someone just checking the data. So there's 2 underlying themes of these stories, one of which is automation. This idea that, as I just described, even a person trying to check and manage the data every day, it corresponds to someone doing something that is actually difficult and is also quite easy to automate given the right algorithm. So automation is the underlying theme of this presentation. The other underlying theme then is this idea of disparate data sources. So disparate data sources is something you might hear from your contractors, from your consultants, from the external parties. I know, having been a consultant, that this was a term we used to harp on. Avoid disparate data, consolidate your data, sit everything in a single place. But as we know, there are trends that prevent this. There are ideas behind this that make what I call disparate data an endemic factor of your data ecosystem. In this case, it's proprietary. So another way of looking at this might be collections data or source data, data that's coming into your federal agency that's been brought from external and you don't have control. In our case, in this particular anecdote's case, this was a major bank. This was a bank that was the size of some DoD entities, and they could not control the format of the data, which made it difficult to read and thus that much harder to detect completeness versus incompleteness. So I think about this idea of proprietary data really in the landscape of disparate data sources. I think about opportunities for automation, and I'm impelled to just continue this story on what's next. So if you've accomplished this, if you've solved this problem of good data, how then do you manage bad metadata? Now, metadata is another loaded term. I think about how we could describe it. I think about how most industries describe it. And oftentimes, if you Google metadata or what is metadata, you'll hear the phrase data about data. Now, I like that. I think data about data is accurate, but I want to expand upon that. And I kind of want to use our last discussion on model to really kind of dive into this idea of metadata. So if you had your Excel spreadsheet or your table and you're looking at it and you see a column that says date, well, really the column says the letters DATE, but your brain interprets that to be date. You look at this column, you might see what appears to be 2 numbers, dash 3 letters, dash 2 numbers, or 2 numbers slash 2 numbers slash 2 numbers. Either way, you see what you might recognize as a pattern for a data of date. You see that this column is date, and then you realize that your spreadsheet is time series based. You know that your data has a time element or a time component. Now your brain took data about data and actually did something a little deeper. It profiled it. it profiled that data, effectively turning it into information to allow you to better understand your data. So I would assert that while metadata oftentimes getting described as data about data is good, I think describing it as really information about data is a touch more accurate to the use case of how metadata evolves. So that's where we come to this idea of how do I profile our data consistently? And I would then tell you a story. So I was, again, at this point in time, I was consulting. I was working for a lineage team, actually working for a nonprofit that was being sponsored by a government-sponsored entity. We were tasked with providing lineage, data lineage across the entire organization. And what we produced was a bunch of spreadsheets. And I'm sure anyone who's ever had to do manual data lineage knows the pain of that level of spreadsheets. Now, our documentation was exhaustive, and thus it was conclusive. So if someone wanted to trace lineage, they could do it. It just took a really long time. And that prompted the chief architect, the person who was one of our sponsors, to say, hey, is there any other way that we can ingest this? I have an idea, something like a data dictionary. I'd like for you to be able to condense all of this metadata into some easy to read catalog so that people can follow the technical lineage a lot easier. So we said, sure, why not? And we placed a bid. Now, automation, right? So the theme of automation, I had this good idea that I presented to my management. Maybe we can automate profile. I mean, the technology should exist. We should be able to trace this lineage and be able to automate it. And so we opted to do that. And that's how we wrote up the proposal and placed the bid. So we won. We were given the opportunity to do this lineage, and we did, in fact, automate it. Now, the automation worked really well. It did everything it intended to do with one caveat. So 80% of the data was a certain type, 20% was another type. So 80% was in an XML capacity, 20% was in a comma separated value or a CSV capacity. And this automation missed that 20%. So what we had was a document that was incomplete. So unlike our very manual process that had very complete lineage, we then are faced with a situation of having an automated process that was incomplete. Now, this wasn't a costly mistake other than my weekends, because I had to go and kind of catch up and do the manual documentation of lineage. But we're talking about something that when your margins for predicting your revenue are a certain way, and anyone out there who's doing government contracting or consulting, this idea that if you've bid on something, you expect your cost to be at a certain rate, and technically our costs exceeded that. So we got ourselves into a situation where we realized we need consistent profiling to achieve consistent results. I think about this idea of automation. We are in a process of turning data about data into information about data, or metadata. There is definitely a way to automate it. But what caught us off guard is this idea of the CSV data. Now, why did it catch us off guard? Why did this happen? So I think about this use case. One of the things that this organization had that we were working at was private data. Private data that was coming from customers who had a special arrangement with these organizations not to share or commingle the data. Now, I say commingling because that kind of sounds a lot like classified data. When we think about this idea of private data or classified data, the reality is it's going to sit on different systems. Special access programs are going to have different data. And as a result of it, you could say that in keeping with this theme of disparate data sources, private data is going to be one of those. In the case of government, this could be classified data. So as we tell this story of proprietary data sources, or excuse me, of disparate data sources, we have this one idea of proprietary, something that's coming from another organization, but then we have this idea of private data. And as a result of this private data is really kind of driving this idea that we won't necessarily have it all in the same place, and we won't have it all in the same type. If you're being audited, you have to keep this data separate. So then how do you manage that automation amidst what could be different data technology? So we've accomplished this. If you've solved this challenge, you've now produced what we call good metadata. But then there's this idea of bad rule logic. Now notice I said rule logic. So for anyone out there who has built a data quality program or appreciates the context of data quality, they can understand that there's this aspect of writing rules. So something is wrong with your data, you want to prevent it, some bad quality, some quality control needs to exist, and so you've written a rule. And as I said here, what rules should I write? So I was trying to explain to my cousin, she's a librarian with the Fifth Circuit Court of Appeals, and I was trying to explain to her what I do in the world of data governance. And it's worth taking a time here to compliment and really show admiration to everyone on this call in the tradecraft of data governance. Because when she heard what I said, she said, oh, wow, that sounds like being a really complicated librarian. And I thought about that. So you think about data governance, this tradecraft of organizing the operations around data and how difficult that is. You think about someone like a librarian, their job is to enact governance around books at their library. At least that's what it used to be. And there was something then called the Dewey Decimal System, a system for organizing. But if you think about that librarian, right, that librarian knows what a book might be classified as. They might read a lot of books, have an understanding of some of the content. But if they were at a university, they would not know that book as well as the author of that book, who could happen to be a professor at that university. So how do you do quality control? How do you do quality control against data that you may have not originated? So when we think of the government context, let's say this data was being created by operators. How do we work with these operators to ensure quality control? There's this idea of writing rules, and what rules should we write? But it's made difficult by the fact that the experts of writing those rules might be associated outside of the data governance space. But then it gets trickier because those rules don't also necessarily mean that we will predictively prevent bad data quality. So this is what happened in my case. So my background is in the government. I've had a few years with the government, but then I was also in financial services. I received an MBA with a concentration in finance. So one of my first consulting jobs was to be a business analyst. I was paired up with a full-time employee at the organization. So I'm a contractor paired up with another representative of this agency. This persona in this particular case also had a strong finance background. We were given mortgage data with an intent of writing rules to prevent bad processing of this particular financial data, these what we call derivatives. So we sat down and we wrote rules. We were pretty proud of ourselves. We came up with over 100 rules that first sprint or iteration, effectively 3 weeks. Those rules were then codified, and we'll get into what that means, but just know that it was another 3 weeks to process the rules and then another 3 weeks to test them. So we're talking about something that from a contracting or a consulting standpoint could definitely run you into the tens of thousands of dollars. We've written all of these rules, but wouldn't you know it, that when we actually started testing it against real data, not a single one of those rules broke. Not a single one of the 100+ rules broke. Why? Why didn't that data quality check work? Why didn't that quality control exist? Well, in this particular case, the data that was breaking down was technical. The issues were systems related. We were having quality control issues, but they were not related to the business. So I think about that, right? What's maybe an example? We wrote a rule that says a mortgage term. So people here have mortgages, hopefully, if not, your rent. But this idea that your mortgage should go down every month. Now, there's reasons for it not going down, but we wrote the rule to say your mortgage should go down. Now, your mortgage can go down, and in some very rare cases, it can be paid off down to zero via a refinance, et cetera. But your mortgage generally shouldn't go from 100 months less to zero without it being paid off. But this is what was happening. This was happening because of something called a race condition. The data was getting processed. it was being force-fed, nullified, and because a null was not allowed, they were defaulting it to 0. So some bad code combined with some over processing forced these values to be 0, and we were missing it. So I think about this, right? And I think about human rule writing. The reality is it's error prone. We go back to the analogy of my cousin, the librarian. If she was tasked with quality control of the books, why would she not just use spell checker? Yes, the college professor might know some of the more advanced things in quality controls of that book, but at the same time, in her particular case, if she was in charge of that, there's got to be a way to automate it. So this is then this idea of automation in your rule logic. What if we could do a base level of rules, apply an initial rule set that's more profiling based? It goes to look at that metadata, because that's what me and my buddy ended up doing. We stopped thinking about what could go wrong from a business context and started to think about what could go wrong from a metadata or profiling context. So if you imagine then pulling your data, doing profiling, look at those profiling results, and then comparing those over time to see what might be wrong. A field that you know is very important, we'll call it a classification or a portion marking. You would expect it to be there, and if it's not there, then something's wrong with your data. So this was actually how we started doing it, but I have to imagine that could be automated, and that's something that I would take with us. So you've now reached this idea, this nexus point of good rule logic, but then this idea of bad scale. Now, what do I mean by bad scale? I almost mean bad rule syntax or bad rule codification. I said we would talk about what that means for rule codification, and I think it's worthwhile. So imagine you've created a spreadsheet, and you have your spreadsheet and you want to do quality control on it. People are contributing to it. You've put it up on SharePoint, but you want to have quality control. So you might do things like lock down certain cells, or maybe at the end of it, you might do a count of your cells, or you might do some function. Now that will require you to write the equal sign statement, one of these conditional statements in Excel. That's this idea of codifying a rule. When you have a logic set, as you might have in Excel, you need to turn it into something that can be then machine readable. Now, in most data quality programs, this language is SQL, or what we know as structured query language. So we're executing rules against the data based off a querying language, and if any results return, that implies that the quality control has detected something that's wrong. So rule logic becomes rule scale, but this can be very difficult. You get to a point where you wonder, how do I manage my rules? So in my particular case, or in this anecdote, we have this idea of a technology team. So I was now a product owner for data quality tools, working with a data quality operator set. So a team of a lot of people focused on writing data quality, making data quality control, writing the rules. And they were a very robust program. They had been around for a little bit, and they had written 30,000 rules. 30,000 rules using a software that helps them take the rules and put it into that coding syntax. So again, you think about automation. How do we avoid the developer here? Almost as though if you said, hey, I'm writing this stuff in Excel, it'd be really nice if something helps me write the if statement, or writes that equal sign summation statement, some open parentheses with the values. So they were using the software, and the software was effectively making the SQL for them. But there was one catch. SQL, as we know, takes many different forms. So imagine your if statements in Excel versus your if statements, if anyone out there uses Google Sheets, or if anyone remembers Lotus Notes, or even something like Access, which has a tabular form, but uses a different syntax or a different code. SQL can vary. And proprietary SQL is oftentimes the worst to deal with. So we were at a pivoting point where we were changing from one database technology to another. We were transitioning, and we said to the vendor, hey, we need you to support this data technology. The vendor says no. The vendor says, I'm not supporting this data technology. It's not on the roadmap. We will get to it in a couple of years. And we say, yeah, but it's our priority. We're one of your biggest customers. And they say, well, that's fine. It is what it is. So first we asked for the rules, and initially those rules were encrypted. We didn't actually even have access to the rule code until we finally got it. And when I say this syntax was confusing, the code was so illegible for us, unreadable, that it was going to take a very long time and a lot of manual effort to translate those 30,000 rules. Now I say that because when you have that kind of altercation with a vendor or a contractor, and you know they have you for a couple of years and they've reached a bidding point, the reality is you might be stuck with them. And in this particular case, this is something that cost well into the 7 figures in terms of our relationship with them, because we couldn't lose the software. We needed it to maintain quality control. So ultimately, there is a franchise risk proportional to your DQ rules. So we mentioned this idea of automation. What can we do to codify these rules, to write them in a way that is consistent across many different database technologies? Something that works for Oracle the same as it works for Postgres. Something that works for your Excel spreadsheet the same as it would work for a database table somewhere else. So you think about writing those rules, and you want this rule to be able to be migratable. Now, I say migratable because we've reached our third topic of disparate data sources. So we talked about proprietary data, data coming into the organization. We've talked about private data, data that you're required to keep segregated. Now there's this idea of premier technology, a third use case for where your database data will sit in a disparate data source. So if you made a bet on AWS 10 years ago, 7 years ago, excuse me, it would have been a great bet. You would have been happy with it. It would be paying dividends. But should you necessarily be locked into that technology? If over the years something like Snowflake takes off, you would want to be able to move your data into the most relevant database technology. Now, everyone who's ever done a data migration knows that, as I've just described, it can be enduring, but really it's also very difficult. And it's hard enough to make sure your data migrates effectively. It's even harder than to have to migrate the metadata. And in this case, those rules were not migratable. What we want is to be able to write our rules in a syntax that speaks across different databases or disparate data sources. There are ANSI compliant SQLs out there. There are this idea of creating an intermediary data frame and processing SQL over it. But the key theme here is, how are you managing your DQ rules? Because the scale of those rules can cost you dearly. So here we are. We've had this idea now of creating our rule logic, reaching that rule scale, and now you have good scale. But then there's bad notification. Now, notification are really like workflow. This is the tip of the iceberg. This is the kind of focal point that everyone has, that everyone sees. But we can see there's a lot underlying the foundation of it. But I think it is important. So I would use an analogy and go back to why data governance is difficult. You're at an organization, and the Office of the Inspector General calls up and says, hey, I'd like to talk with you. We had an operational risk incident. Something is going wrong, and we'd like to get your feedback. Well, you're going to take the call. You're going to take it seriously. If your SSO is calling you, if your technology team is calling you, let's say the tech team is calling you, and they say, hey, we'd like to discuss your trouble ticket. We want to help you get your email back up and running. So in the case of the former, we've talked about this idea of risk. Risk is prioritized by every major organizational leadership. The OIG is taken seriously. The risk organizations are taken seriously. And thus, you know that that's one of the ways that you can be fired from your employment, is by violating a risk practice and procedure. On the other hand, we think about technology, which is just enduring to the everyday user. You have your email, and you just can't afford to not have it. So when someone calls up offering to help it, you take that phone call. What if you got a phone call from your data team, from someone saying in collections, saying, hey, we've noticed this data source, we wanted to talk to you about it. Is that a call you take right away? Is that a call you prioritize? Maybe it's a call you send a voicemail, or maybe it's something you push out and say, yeah, I'll get to it. That's what makes our industry so difficult in the frame of data governance. When I think about the chief data officer and that role, more often than not in industry, I see that role layered. I see that role sitting several layers under. If that role is an SES, it's again under several other SESs before reaching one of the undersecretaries or the heads of the organization. So that role in commercial tends to rarely report to the CEO. And then in the case of government, that role also tends to not report to the highest SES or the commander in charge of the relative organization. But it is important, and we know that. We know the impact of what could happen if this was failed to take seriously. And that makes this workflow so important. How do I respond to issues? Who owns them? So the ability to provide someone with a workflow that documents the RACI, documents the responsible, the accountable, the consulted, the informed, and provides them a way to point and click their expectations through relative to data is of the utmost importance. Now, I will share with you then a story about that notification. At this point in time, I'm a senior director. I'm in a senior director role, but I'm in a position working adjacent to data. So I'm in a product position, but I'm there to help consult on a data issue with some data quality. I'm working with an individual, and she's a rule writer, and she has her team doing data quality operations. And I asked her, I said, hey, so you have this data quality results. What do you do with them? And she said, oh, well, we automatically send an email to the business, to the front office, to the operators, to the originators of the data. And I said, oh, that's great. Well, what happens when they affirm it's a data issue or a data quality issue? If they say, yes, this is an issue, how do you rectify it? And she's like, well, they don't reach back out to me. They open up a trouble ticket. So I said, okay, I guess that makes, that seems to be the process that you have in place at this point. Now, I happen to know the person in charge of one of the programs that she was sending a lot of the data quality results to. I go to this individual and I say to him, hey, Bill, what's going on? Do you get these emails? And Bill's like, yeah, I get these emails. I get these data quality notes. I just figured someone on my team was taking care of them. So we looked at the email, and when you know it, of the 15 or so people on the distro, 13 of the emails were dead or had been moved on. As to say, there were only 2 relevant people who were focused on this email. So that's a tough situation. What you're dealing with right now is bad data quality that has been reported and sent to a business or sent to an originating unit that could stand to get in a lot of trouble. In financial terms, the real risk exposure in this particular case was nearing 8 figures. Now, we addressed it, but this could have been a really big deal. Think of it almost like a spillage of classified data, and it's been existing for a while and getting reported. So this is bad, right? This is upsetting, and the person in charge is really upset. And he looks at me and he's like, yes, this stuff is wrong. How do we fix it? Can you go take it back and fix it? And I said, well, Bill, you got to open up a trouble ticket. And he just went off like, well, what do you mean? What does that look like? You guys are all IT. I don't understand. So we kind of think about that situation, this idea that data workflow can not only break something, but then this presumption that we are all associated with the chief technology officer. And thus this idea of really how a trouble ticket gets managed, if everything's a ticket, as it tends to be at organizations. So whose job is it to fix bad data? And this is where we get into, we really need a clear ownership and governance model, but we also need technology to support that self-service software model for adoption. What does that mean? What does that look like? I think about some of the agencies that are taken very seriously, and then I think about some of the agencies that are taken seriously sometimes. HR is a good example. So we know HR during our performance reviews, we know HR doing its mandatory training, we know HR during our entries and our exits, and then if we have any disputes. But oftentimes day to day, there's a factor that HR really cares about: leave and vacation. So we know we should take leave seriously. It's a serious thing for our employment. Some government agencies track it very closely. But if it was not prioritized, would you actually be putting in your leave hours? I know a lot of people who normally say no. They have arrangements with their bosses. They leave early. They do their 59 minutes every day, and it's a handshake agreement. But the reality is putting in your time, tracking your time, recording your timesheets is essential for some of the metrics that HR produces, and it's important to that leadership. So we know it matters. So then, in addition to getting it prioritized, how does HR make sure that we know it impacts the everyday individual or user? This idea of this workflow, this self-service software with minimal clicks that allows you to put your time in, allows you to copy your time week over week. And as a result of that, because this time entry has now been reduced from punching a card, from filling out forms manually to a few clicks of software, when someone does prioritize it, there's little excuse for why you are not doing it. And that's the goal here. That's the goal behind your workflow. Now, I know I said workflows is tip of the iceberg. There was some visualization hint there. This is my Maslow's hierarchy of data quality needs, if you will, the stack. This idea of what is a good architecture for your data quality program. We look at the layers and we see highlight high to these painful stories. So this then is that insight. Having heard the pain, having seen tidbits, how do we bring it all together to build your data quality program? So what you're going to want is good data, the ability to integrate across multiple data sources. We've talked about the 3 ways of disparate data and why it's endemic. This idea of proprietary data, data coming into your organization that you don't control, private data, data that you're forced to keep on different systems, and then premier technology, this idea that when you move from one technological source to another, you now have to consider data is going to sit in disparate places for a period of time during that migration. So you need to be able to integrate across multiple data sources in order to effectively employ data quality. You then need to profile your data consistently. The metadata output needs to match despite the various amounts of inputs. And this goes back to that example of having CSV data matching XML data. The data itself will never match, but the results or the metadata about that data can have consistent formatting. At which point then we get into this idea of automatically detecting change. Good rule logic can be automated. This goes back to that theme of automation. Those first 3 layers are able to be automated. And when we think about that, that's then this idea of applying minimum viable data quality trust. Now, what do I mean by minimum viable data trust? If you're running those 3 things effectively, if you have coverage across all of your data sources, if you know you're profiling it or you're cataloging it consistently, and you're running an automatic layer of data quality, as long as nothing's going wrong, you've achieved some data trust, more so than any other program you could have had in place, any other manual set of operations. Now, we know things are going to go wrong. And when they do, this is when you find yourself having to write maybe more advanced rules. And then this is this idea of having good scale. What can we do to templatize or standardize those rules so that they will continue to endure despite the technology that you use? And then at the very top, when you have these things that are wrong, how are you actioning them? How are you carrying them further? How are you getting them to the operators or to the agents or to the front office of your organization so that they can respond to it? Now, I say all these things. I am partial to the offering that Collibra has. I do think that our data quality and observability solution meets that, but you should always consider solutions in the market that combine the 3 trending features to modern data quality. Advanced autometrics, what can you do to automatically detect change? Rule templating that ties to standardized rules, and data discovery and enforcement. And that's this idea of being able to apply those rules as well as profile consistently. So I'm going to just take a second here and open up for questions. I think it's an opportunity to get results from the audience. Happy to answer some questions and look forward to digging in a little deeper.
So I didn't see any questions come in from chat. Just trying to reach out. Feel free to come off mute if you have a question. I don't know if we can, Courtney, if we can allow them. Let me look at the Q&A here. No open questions. Is there any questions or anything that we can focus on relative to today's discussion?
Yes, I actually got some questions personally from the chat, so I can just read them off right now.
Yeah, that'd be great.
Someone asked, how long does it take to implement data quality program?
Oh, that's a great question, right? So how long does it take to see success from a data quality program? That can be in as little as weeks or months. So what I mean by seeing success initially, if you had a use case, right? A use case for where you're trying to implement data quality, you know that you're seeing these issues. And let's just say you download some software and install some rules, or you put something in place to prevent it. Maybe you tell your employees they have to click twice to verify that their data is correct. That is a data quality control, and that is you implementing data quality. So in very short order, you can achieve a data quality success. Now, when you get into scaling this out or just dealing with data that you might know something is wrong, but now you have to discover it, our software takes a lot of pride in being able to get you there very fast, again, in weeks, not months. But when you look at a scaled program, actually rolling this out to your entire organization, that's going to be the it depends. It's going to be the it depends because how big your organization is. I've seen this rolled out at banks who literally have banks underneath them. So even like, to use a government context, imagine if we said, okay, we're going to roll this out for a naval command versus a fleet versus the entire US Navy versus then the Department of Defense, which would include the Navy and Army, versus, oh, we're going to now lump in Coast Guard and DHS, Department of Homeland Security, and capture the entire executive office. So the time for rolling out is largely going to depend on the size of the scale of your project. But when it comes to knowing you want to achieve data quality for a specific use case or a specific instance, you can definitely do that in a matter of weeks, especially with an automated solution.
Perfect. Thank you so much. And a second question that just came in is, can you showcase Collibra's product stack and capabilities and case studies?
Oh, absolutely. I look at the time that we have. I would be remiss to try and show a bunch of slides or a demonstration. I mean, this is a really great question. I think what we'll do, we'll take a note here, Vasan, and we'll actually join. Now, I see that second question. Both of them talked about the problem only and not explained how Collibra solves the problem. So this is fair, right? I would caveat that the goal here is talking in almost a philosophical sense, right? That the topic of data quality and how we solve it. That's why we give a theoretical stack and we don't prescribe technology. That tends to be an ask for these types of sessions, right? What can we do to bring thought leadership to the problem set? Now, I bet my career, I went from being a DQ operator. Okay, perfect. Yeah. I'm seeing more questions coming in. Thanks, Hassan, as well. So coming in as a operator to then work with Collibra, I'm passionate about the technology, and we're definitely happy to talk about how our technology solves this problem. There's that one little spot, that one little blurb in the previous slide that kind of talks about what Collibra data quality and observability does. But for anyone who wants to understand how we approach that from our technological standpoint, we're definitely happy to dig in, and feel free to reach out either to me directly. I can put you in touch with somebody. Everyone on this call should have an associated account rep, so we can find who that person is and get you sorted. Yeah, so I saw then the third Q&A, right? We do have Collibra implementation. We collect all the metadata and source information, but we do not know how to leverage the value from the tones of the information collected. That's a good question, and I'm seeing that come in from an aspect of data governance, right? Metadata catalog. The key theme, right, is this idea that if you have it organized, you can sort it and you can get to it faster. So when you say the leverage the value, to me, the value is knowing where it's at. Most organizations struggle sometimes to even know where their data is. And that is a very difficult challenge. So our offering for catalog is this idea of knowing where you can find it and doing it in a more simple way. I'll go back to the anecdote I said about the data dictionary. It was, I want to say 40 plus tabs on a spreadsheet, our lineage that we had charted out. So if an individual, right, if an architect, if a business designer, if someone involved in this technology of this institution wanted to understand aspects of the underlying what they call canonical data model, they had to go through each tab. They had to basically build their own cataloged information. So by having that data dictionary, we had it more consolidated, and we had it in a streamlined way that would take them minutes and not hours to find the information that they need. So maybe in this case, because you have it already in place, but when we think about the implementation and rollout, this used to be filing cabinets. If we think about the original data before we even stored it digitally, it was files and cabinets. And then it became files on computers. And then we got into this idea of actually structuring data in a database. Now we have all this data, information, insight, whatever you want to call it, sitting in many different locations, disorganized. That's what Collibra's value proposition is. We can at least allow for an organized layer on top of that through things like the catalog, which will actually consistently organize it. Governance, this idea of allowing you to actually make a workflow. Think about what the Dewey Decimal System is, referring to the librarians. It's really just a workflow and an execution of a model. Our data governance helps you that. And then lastly, then there's this idea of quality, making sure that your data is fit for use because you know that it has quality controls with it. So I think that's a broader question on value, and I am very, very happy. We can take this offline. I got your name. We'll get your email. We'll reach out, and we're happy to.
Perfect. Thank you so much. And our next question is, what does the future look like for data quality programs?
Automation, scale. So most organizations will talk about critical data elements, and oftentimes this is a place to start. What are the columns that you care about the most? What are the elements that you need to understand? And I'm trying to think of various ways to phrase this, but if you were at an organization, let's say Department of Treasury, and you know that in order for your business to operate, you need these particular fields. These are the data points that you need. That's your kind of like your golden data, and what we in the industry call your critical data elements. So if you're an Intel company, these might be the key nodes that you need to understand relative to your 5 ints or your 6 ints, whatever, however you break your intelligence, your categorization down. But in something like human, this might be the TD serial or the IIRR serial. But you need that data point. So you organize around that data point. What we're seeing now is you get to a point in size where, just like data becoming so overwhelming, even critical data elements start to hit into the tens of thousands. So scale and automation are going to be the two focuses. And really it's scale, but using automation to get scale in order to allow you to get better in the vein of data quality. That's why we think our particular software is forward-looking. What our software does is actually helps you write rules and identify what might be wrong with your data from a quality perspective. That didn't really exist in an offering before the startup came out with it, and then it was acquired by Collibra. So it was a novel approach. What's next then is, how do we tie that into the other aspects of data governance or the data intelligence cloud? Can we look at what might be wrong and then automatically trace that to lineage? Can we look at that lineage, or can we look at that data quality, produce a some metadata about it and tie it to your catalog? So now when you're shopping for your data and you say, I really care about this field, let's say that field is social security number. We know that we care about social security number, but we know that it's stored 15 different places at our organization, and one of them seems to have a lot better of a quality score than the other 14. So our software, automatically detecting data quality, at least looks at this column and says, hey, we're not seeing anything wrong with it. So your automation tripwire, your first line of defense, is saying nothing's happening, nothing's going wrong. Whereas for the other 14 columns, or the other 14 instances of social security number, it is saying something's wrong. So now from a catalog perspective, you know what columns might be better fit for use if you have to do analytics today, but you also need to know then where you need to invest your time to improve quality. So I do think quality, that the future of data quality is scale. I think automation is doing that, and that's why I'm really happy with the Collibra offering, because it is automation focused.
Awesome. And I think we have one more question coming in. And the last one would be, what is the biggest challenge you have seen for data quality resolution workflow?
Solving at source. So data quality resolution workflow, if you think about it, right, the data governance tends to own the process of detecting. When you get into resolution, it oftentimes then might fall into like a data engineer persona, or executing like within a CIO versus a CDO. And how that persona chooses to fix sometimes then falls out of the scope of your control, let alone this idea that your business matters. So if you were, we'll pick a government agency like the IRS agents, right? The people who are doing audits are collecting and helping manage data, and they're using it, right? They're using analytics to see who is a better audit target, right? Who falls into a higher audit risk category. So they care about the data, they care about the results, and they're part of data entry. But let's say a field was wrong. Let's say the income of a recipient didn't include the deductions, where was some bad math. So we have bad data quality. You're in a data governance space, you detect it, and then you say, hey, let's resolve it. And the IT department says, okay, and they fix it right there on the spot. So they fix it where you've detected it, which could be downstream. It could be in an analytic lake. When the reality is, the way to fix this is upfront with the auditors at a point of data entry, require that they actually link the income to the deductions. So when we think about how we solve for data quality, we tend to detect downstream, and that's okay. And we're trying to push detection upstream. But even if we detect it upstream or downstream, fixing at source is critical. And because IT oftentimes implements the fix, we don't necessarily see that fix occurring upstream. This is why we get into new concepts like data mesh or data fabric, this idea of giving the business owners a stake in the data game, so that when we say, hey, there's a data issue, they can say, well, this is really just occurring because our front office only has 2 fields. I was talking to someone, she was a municipality, and she was explaining that the police have this problem because when the police fill out a record, they really only have 3 fields to choose from for demographics, when really there's a much greater definition set there. So what they needed to do was expand that demographic list, maybe even consider making it free form. That might be a quality issue in and of itself, but the being when you only had 2 to 3 options, you were grossly over categorizing or under categorizing or incorrectly categorizing the demographics of the individuals involved in these police cases. So that is a challenge, and that's a challenge up front, but that was solved with process, not necessarily just with technology. So this idea of resolution then is really a challenge because it involves people, process, and technology. And we oftentimes just kick it to the technology owners. And I think that they tend to fix downstream.
Perfect. Thank you so much. We're just hitting around 12. So we just want to thank you for everyone who came out to our webinar, and thank you so much to Eric for being us today.